In this video, I am going to look at annuities. Annuities are things like superannuation, where a certain amount of money is invested at equal intervals over a time period. So it's not like when you invest once and your investment grows over a period of time, say $10,000 for 5 years, but more the case of, let's say, you're saving for a trip and you decide every week you're going to put $100 aside, but rather than just putting them in a drawer, you're investing the $100, say for a period of 2 years, and you want to know how much all those hundreds as invested add up to at the end of 2 years. This can be a bit tricky, and there are details that you need to pay close attention to. I'm going to try to address as many as possible. We're also going to look at how tables are used in this type of questions. So let's have a look at this example. Frank's parents put $1,000 in an investment account on each of his birthday, with the final deposit on his 18th birthday. They give Frank the total amount as his 18th birthday present. If the investment account returns 5% per annum compounded annually, how much will Frank receive? Okay, so there's a lot of information there. I am going to create a summary and also a timeline. So my principal, which is the amount that's being invested in each time interval, is $1,000. My rate is 5%, so 0.05. And now the question is what is going to be N? Now, this isn't similar to a investment of a lump sum, but more similar to a home loan. Because if you recall, with home loans, we have to look at every month separately to devise a pattern. It's the same case here. So I'm actually going to leave N off for now, even though I have this 18th birthday. Rather than do that, I am going to draw a timeline. And I'm going to start at point of birth, and then I'm going to have first birthday, second birthday, third birthday to establish a pattern, and then I get to the 18th birthday. So the first amount of $1,000 goes into the account. It says on each of the birthdays. So not at when Frank was born, but the first amount goes into the account here on the first birthday. Well, I will come back and look at the rest, but let's just work with that. If I've put, let's call that amount 1. Amount 1, $1,000, sits in the bank account and collects interest for how many years? So if I count these, that would be 1 year, 2 years. So at birthday 3, it's accumulated interest for 2 years. So by the time I get to 18th birthday, it's accumulated interest for 17 years. So that would be 1.05 to the power of 17. So that's amount 1. Now we go to $1,000 on the second birthday. So another $1,000 goes into the account for investment, and this $1,000 sits in the account. That's 1 year by the third birthday, 2 years by the fourth birthday. So by the 18th birthday, that would be 2 less, so that's 16 years. So amount 2 accumulates interest for 16 years. Amount 3, looking at the pattern, would be $1,000, 1.05, 15 years. If I follow that pattern, when will be the last amount? So the question says the final deposit happens on the 18th birthday. So $1,000 does go into the account on the 18th birthday, but then the money is also paid to Frank on his 18th birthday as his present. So that last $1,000, if my first one was on the first birthday, amount 1, amount 2, amount 3, the last one would be amount 18. And it sits in the bank account for 0 years. So the total amount, I'm going to call this the future value of the annuity, is amount 1 plus amount 2 plus amount 3 all the way to amount 18. All of those amounts have 1,000, so 1,000 is a common factor. And then we've got 1.05 to the power of 0 here, which is just 1. And then 1.05 to the power of 1, 1.05 to the power of 2, all the way to 1.05 to the power of 17, which was my amount 1. Now, I need to establish, for these types of questions, again, we need to establish a pattern. I highly recommend drawing a number line and then doing A1, A2, A3. Then you've established your pattern. You can go to the last term and then write your sum to calculate the total. This is a geometric progression. My first term is 1. My common ratio is 1.05. Number of terms, there are 18 terms. So we're going to the power of 17, but we started with power of 0. So my future value is 1,000. And then using the sum of a series, that would be 1.a times a is 1, common ratio r to the power of n, which is 18 minus 1 over 1.05 minus 1, which is 0.05. Now, if I do that calculation, I get $28,132.38, again to the nearest cent. Similar to loan repayments, questions can get more complicated by twists introduced, change of amount part way, period of no payment, interest rates increasing, all sorts of things can be introduced. And if things are introduced, they are separated over a period of time. You treat each section separately. You do the first, and then any carry-on information into working at the second part of the problem. Apart from that, these questions can refer to tables. So if the question is worded this way, then you must use your advanced and geometric series knowledge to solve the problem. But the question could provide you with an annuity future value table and say, using the table, work out the future value. So that's what we're going to do now. We're going to take note. The first thing we need to do is make sure we highlight and identify the number of terms. So number of payments over here, we've got 18 years. And we are going to take note of the rate, which is 5%. Our amount of investment is $1,000. So let's go to our table. So here is a table of future value for annuity of $1. Our interest rate was 5%, and we were looking at 18 years. So bringing those two bits of knowledge together, we get 28.1324. So how do I set out my solution here? I write future value equals 1,000 times 28.1324 from table, and then I do that calculation. And in this case, it's straightforward. It's $28,132.40, which you can see is pretty similar to the answer we had earlier. So if it's a table question, the space on the exam paper for working out will be limited and the marks will be limited. If it's not a table question, then the question will be worth more because there's a lot more working out that needs to be done. So you need to establish the pattern, that's worth some marks. You need to establish the series. You need to state that it's a geometric progression, and then you need to apply the sum equation. That's a lot more work and a lot more skill than reading the information off the table. Let's have a look at another example. So Frank decides to invest $2,000 each year in an investment account. If the first amount was invested at the beginning of 2020, that beginning is really important. What would be the future value of Frank's investment at the end of 2030? If the account pays interest at 4% compounded annually. Okay, so notice this question's different to the last one because here we're looking at investment happening at the beginning of each time period. In annuity questions, you can assume that the payments are made at the end of each time period, a bit like this birthday where the first payment is at the end of the first year. So you can assume that's the case unless the question tells you otherwise. So let's make our summary. Our fixed amounts going in are $2,000 and our rate is 4% compounded yearly. Again, I'm going to do a timeline. We are going to start with 2020. That's the start of 2020. 2021, that's the start of 2021, end of 2020. So what we need to finish with, let's just put 2022 in as well, because we need really 3 to establish a pattern. This is the start of 2030, but we are going to the end of 2030, which is the start of 2031. So a timeline really helps clarify how many terms we have. Our first amount of 2,000 goes in here, and then another 2,000 and another 2,000 and so on. Now, the last amount goes in at the start of 2030. Here is the end of 2030, beginning of 2031, but we'll never make it into 2031. We finish at 2030, end of 2030. So there is no final payment at the end here, unlike the previous example. So let's do our calculation the same as before. Amount 1 was $2,000 and it sits in the investment account accumulating interest. The question is for how many years? So if we started at the beginning of 2020, then by the end or the start of 2021, that's 1 year. That's our second year. So by the time we get to 2031, that has been sitting in the account accumulating interest for 11 years. Amount 2, 2,000. It's been sitting in the bank account for one less year, so that would be 10. Amount 3, 2,000, one less year, and continuing that pattern, our last amount is here, 2030. The question is that amount number 10 or number 11? Since my first was on 2020 and my second was 2021 and my third was 2022, then at 2030, that will be my 11th amount. So there are 11 terms here. A11 is 2000, 1.04, and that accumulates interest for 1 year. So my total amount or future value is going to be amount 1 plus amount 2 plus amount 3 and so on until we get to amount 11. Let's add them up. They all have 2000 as a common factor. 1.04 to the power of 1 plus 1.04 squared plus 1.04 cubed, all the way to 1.04 to the power of 11. Just like before, we write this is a geometric progression with my first term being 1.04, common ratio is 1.04, and number of terms is 11. So my future value is 2000 times A outside of common ratio 1.04 to the power of 11 minus 1 all over 1.04 minus 1, so that's 0.04. Calculating that gets me $28,051.61. So let's have a look at one last example, which is purely using the table to answer the question. So Frank invests $1,500 per annum. So that's the principal of investment. So P is 1,500. And an annuity with a rate of 7%, so 0.07, compounded yearly for 20 years. Okay, so really straightforward. They've identified it's exactly 20 years. We're assuming it's happening at the end of each time period. So the last payment goes at the end of the 20th year, and then it's withdrawn straight away. So everything's set up nicely. Using the table, find the future and present value of the annuity. Now, future value is straightforward. It's the total lump sum that we have at the end of that time period. So we can work that out straight away from the table we just used. So in our table, we are looking for interest rate of 7%. So let's remove this. So rate is 7%. My time is 20 years. So if I go across until I get to my column, I get 40.9955. So going back to my work, my future value is 1,500 times 40.9955. And when I do that calculation, I get $61,493.25. Now, the second part of this question asks for the present value of the annuity. What this is asking is, if instead of $1,500 being placed into a annuity every year, what if we wanted to place a single lump sum at this moment in time, with the aim of having exactly the same amount at the end? So how much do I need to invest as a single investment today so I end up in 20 years with $61,493.25? Now, the question here is asking for us to use the table. So we are going to do that, but afterwards I'll show you if this was not a table question, how do you go about answering that question? So present value will be 1,500 multiplied by the value for 7% at 20 years in our table. So if I go to my present value table, look for 70%, which 7%, which is here, 20 years, and I will get my value of 10.5940. So going back to our work, if I multiply this by 10.5940, I get $15,891. So if I don't want to spend the next 20 years every year putting $1,500 in an investment account, I can invest nearly $16,000 today to end up with the same amount of money. Now, if this was not a table problem and we already had the future value and we wanted to know what would be the present value, then I can go back to my compound interest formula. Future value equals present value times 1.07 to the power of 20. I know what my future value is. My future value that I'm interested in is $61,493.25. So my present value would be $61,493.25 divided by 1.07 to the power of 20. That results in $15,891.02. So that covers our annuities with and without a table.